children, welcome back to our maths period. Today we will continue with our chapter surface area and volume with part 14. Last period we have started with the sphere. Yes, we have seen how to find the surface area of sphere as well as the curved surface area and total surface area of hemisphere. Let us continue with the same exercise. So before that, let us revise the formula once again. So if it is a sphere, we require the radius of the sphere that we will consider as r. And the surface area of the sphere is equal to 4 pi r square. Here the whole sphere is in a curved shape, so we will not take here as a separate the total surface area and curved surface area. We will consider as only surface area. So in exam, if they will ask you the total surface area formula, we will apply the same as well as for curved surface area. Is it clear? So we will continue with the next formula, that is for hemisphere. For hemisphere also we require the radius. Hemisphere is exactly half of sphere. So half of the sphere, therefore you can see here this part is a curved shape and this part is a plane shape. So we will get it here as a curved surface area as well as total surface area. So the curved surface area of the hemisphere is 2 pi r square. So how we got 2 pi r square? How to remember? The total surface area of sphere is 4 pi r square. So half of that is 2 pi r square, because hemisphere is exactly half of that. Then the total surface area equal to 3 pi r square. How we got this 3 pi r square? So the curved surface area equal to 2 pi r square, and the base, you can see this is in a circular shape and the area of the circle is pi r square. So 2 pi r square plus pi r square, it will become as 3 pi r square. Therefore, you can remember like this way: the curved surface area of hemisphere is 2 pi r square, total surface area of hemisphere is 3 pi r square, and the surface area of the sphere is 4 pi r square. Yes, so by using these formulas, we will continue with our exercise 13.4. So 13.4, question number 6. Find the radius of the sphere whose surface area is 154 centimeters square. Now what is given? The surface area is given. You can see over here the surface area is given, and by using that we want to find the radius of the sphere. Is it correct, children? Yes, we will apply the formula as what? Surface area equal to 4 pi r square. So first we will write the given, that is surface area of the sphere equal to 154 centimeters square. Just don't forget to write here the unit as centimeters square. Then let the radius of the sphere be r. We will consider the radius of the sphere as r. Then start with the solution. Surface area of the sphere equal to 4 pi r square. Always remember how to solve the sum. First we will write given, then formula, substitution, find the answer, and final answer in words. Okay, so 4 pi r square is a formula. Now substitute the values. So now the surface area is given, correct? So surface area is 154. So I'll write it as 154 equal to 4 into pi value is 22 by 7 into r square. Now bring this 4 into 22 by 7 on left hand side. Yes, so what it will become then? Yes, so 154. So 154, if you bring the 7 here, it will go in the numerator. So 154 into 7, 4 and 22 in numerator, it will go in denominator. So we will get r square equal to 154 into 7 upon 22 into 4. Now let us see the calculation part. So the same step I have written once again: 154 into 7 upon 22 into 4. Do you remember in every period I am telling you, please by heart the 22 table, because in each and every sum, as we are applying the pi value as 22 by 7, we require the 22 table. So if you by heart the 22 table, it will be easy for you for your calculation. Now you can see here, I can cancel directly here, as 22 ones are 22, 22 sevens are 154. So I will get it here as r square equal to 7 into 7 upon 4 can be written as 2 into 2. By taking a square root on both the side, what I will get? R equal to 7 by 2. What is the 7 by 2 value? If you want, you can write it in a decimal as 3.5 centimeter. Okay, so our R is nothing but 3.5 centimeter. So we got the R at 7 by 2, and therefore the radius of the sphere, whose surface area is 154 centimeter square, is 3.5 centimeter, because your 7 by 2 value is nothing but 3.5 centimeter. Is it clear to all of you children? Yeah, let us continue with the next sum. 7. The diameter of the moon is approximately 1/4 of the diameter of the earth. Find the ratio of their surface areas. Yes, first of all, understand the sum. Diameter of the moon and the diameter of the earth. Can you see over here? So diameter of the moon is always smaller than the diameter of the earth. Is it correct? So if I consider the diameter of the earth as d, so what will be the diameter of the moon will become 1/4 of the earth. So if it is d, so the diameter of the moon will become as d upon 4. Is it correct? But to find the surface area, we require the radius. Correct? So convert this diameter into radius and then find the surface area of each and take the ratio. Let us see the solution. Yes, so first step will be what? Let the diameter of the earth be d. Therefore, the diameter of the moon will become as what? D upon 4, because it is 1/4 of the diameter of the earth. So, it will become D upon 4. See the next step. In the next step, we will find the radius of each. Now you can see here, as we have considered the diameter of the earth as d, so the radius will become half of that is d upon 2. Then what will be the radius of moon in that case? Yes, so half of diameter of moon. We got the diameter of the moon as d upon 4. Half of that, so multiply by half. So what you will get? D upon 2 into 4 as 8. So D upon 8 is a radius of the moon. Now see the surface area of the moon first of all. So surface area of the moon is 4 pi r. R we got it as d by 2. Substitute over here as d upon 2 the whole square. Correct? So here we will get it as what? The surface area of the earth. This is just for a moon. Now find the surface area of the earth. This step is for this. So the surface area of the earth is 4 pi r square. Again we got the radius of the earth as d by 2. So substitute over here. So 4 pi into d upon 2 the whole square. So the required ratio, what you will get? So this required ratio should be here. Required ratio is, that is the moon upon earth. So the surface area, if you want, you can consider this step as 1 and this step as 2. So divide 1 upon 2. This way you can remember. Yes, so just find the answer. So see the calculation part over here. 4 pi d by 2 the whole square upon 4 pi d by in the first step 4 pi d by 8 upon d by 8 the whole square upon 4 pi d by 2 the whole square. Surface area of moon upon surface area of earth. This step is for this required ratio. So 4 pi and 4 pi will get cancelled. Yes, now see the calculation for the remaining part. Now I will write it in a division form. So it will become d square by 64. Is it correct? 8 square is 64. Divide by d square by 4. Just I have written this fraction in a division form. Just take the reciprocal, that is d square by 64 into 4 upon d square. So d square and d square will get cancelled. So the next step you will get it as 4 upon 64. And 4 upon 64, if you reduce it, you will get the answer as 1 upon 16. So the required ratio is what? 1 by 16. So here we are completed with our exercise 13.4. Now quickly we will revise once again whichever formula we have learned till exercise 13.4. Let us see the formulas. The first one is what? That is a surface area of cube and cuboid. Okay, so first of all, the curved surface area of a cube is 4a square and the total surface area of cube is 6a square. What is the a value in this case? Can you revise for quickly? Yes. So recollect it, that is a is a side of a cube because in a cube all sides are equal. Correct? Now the second one is cuboid. So for cuboid, what we can say as a curved surface area? 2h in the bracket L plus B, and the total surface area is 2 in the bracket LB plus BH plus HL. Now what is L, B and H? L is a length, B is a breadth and H is height. The next one is for cylinder. So what is the curved surface area of a cylinder? Just wait a minute. The curved surface area of a cylinder is 2 pi RH. Correct? So 2 pi RH is a curved surface area and 2 pi r in the bracket R plus H is a total surface area of cylinder. Now again in this case, what is a R and what is a H? So here the R will become as a radius of a cylinder. So here as this is a circle, so this one will become as R and the H will become as height. Correct? So here this is a radius and height. By using that we can find the curved surface area and total surface area. The next one for cone. For cone, the curved surface area is pi RL and the total surface area is pi r in the bracket R plus L. Now which are the components we have used in this? R and L. Just look at here, what is the R value? Yes. So R is a base is in a circular shape, so R is a radius of a base and L is a slant height, and here in this case H is a perpendicular height. And what is the relation between H, R and L? One more formula we have learned here, that is L square is equal to H square plus R square by applying Pythagoras theorem. Okay, so that is a curved surface area and total surface area. Then for the sphere, we don't have a curved surface area and total surface area separate. Both are nothing but same. So, and the formula is 4 pi r square, where we can say r is a radius of the sphere. This is actually in the sphere shape, not as a circle. The next one is hemisphere. Hemisphere, the curved surface area is 2 pi r square and the total surface area is 3 pi r square, and in this case also the r is the radius of the base where we can say here the base is in a circular shape. Okay, so these are the formulas we have learned till exercise 13.4. Please make this table properly in your book and just by heart these all the formulas. Yes, we will continue the remaining sums of exercise 13.4 in next period. So till that, thank you so much.